Hey, what's going on? So before you continue this course, I just want to say that in order for you to get the best out of this course, you better practice as I teach. You better practice as I teach because I want to give you content that will change your career, right? Whether you are applying for other jobs or you are seeking for knowledge so that you can improve your skills, maybe, I want to give you the best content so that you can become a better developer. Now, this is stuff that we professionals implement when building distributed systems, and there's a lot of information that you're going to take from this course. So what I want you to do is to practice as I teach. Take notes, right? And also engage with us. So there's a Discord group. There is a specific channel just for posting questions about this course. So currently people engage every single day, and if you have any questions or things that you're not sure, go ahead and post them on the channel. Hey, what's going on? So I just want to tell you that if you are not part of the Discord community, make sure to join, because for this course right here, or actually all courses on this platform, there is a channel that you can post your questions. If you are stuck, post your questions and a lot of people will jump in and try to help you. And also be part of it. So if you see other people struggling or they have similar questions, then jump in, because that's the best way for you to improve your skills, by teaching others. And I would love you to be part of the community. So go ahead and join. And if you have any questions about this course, post them on Discord. Catch you later. All right, let me give you an overview of what you're going to be learning in this course. So we're going to build this microservice architecture where we'll have a load balancer, and in here within the private network, so on this side you've got the public network, and on this side you have the private network. So we'll build a fraud microservice that talks to customer microservice, and these will basically send notifications through a message queue. So you're going to learn both Kafka as well as RabbitMQ, and then we'll have a third microservice on this side that will send notifications. Each of these microservices will have their own database, and in here you see that I'm using Mongo, but this is just for illustration purpose, because with microservice architecture you can choose the appropriate database for your microservices. Then you'll see that we'll connect to a Docker registry in here, also Eureka server for service discovery, and I'll talk more about config server later towards the end, but you'll see that because with Kubernetes we will not need it. Again, we will not need it. Then Sleuth for distributed tracing. For service discovery, you can find all of these diagrams actually under the description of this video, and you can download and open with Draw.io. I'll leave some instructions on how to open this. For API gateway, you'll see what is an API gateway. I'm going to show you how to use the one provided by Spring, but then I will basically teach you that we should move to managed solutions whenever possible. Then Sleuth for distributed tracing. Message queues, so we want things to be asynchronous, i.e. if we send a notification from this microservice, and let's say that this other microservice takes 20 minutes, it's just a number, 20 minutes, but let's just say that it takes a long time. We don't want this other microservice to hold the connection for that period, because it can time out and it will slow down all the requests. So instead we want to put it into a message queue. So you'll see how this works. We will learn about RabbitMQ first and configure the topic exchange, binding, and whatnot, and you'll see how all of this will work. Then we'll take our microservices, package it into a jar so that we can build a Docker image that contains everything that the microservices need in order to run as a Docker container. From that Docker container, we will run it within a Kubernetes cluster. So you'll see how to set everything up, including Postgres in here using a stateful set, services, pods, volumes, and whatnot. Then I will also teach you about Kafka in here. So we'll have a mini crash course on Kafka, and you'll see how easy it is for us to integrate Kafka within our Spring Boot applications. And I'll leave you with a big exercise for you to change the architecture from RabbitMQ to Kafka. And to be honest, this is it. So I'm really excited to teach you all of this. You're going to learn a ton, and this is what we professional software engineers do. And I'm pretty sure that at the end of this course you will secure the high paying job, or when you go for interviews you can talk with confidence about microservices and how to build them from the ground up. So there's a lot to learn. Let's get started. For this project we're going to use Maven as our build tool, and in this page right here, which you can find the link in the description of this video, you can see that they give you the installation guide for the operating system that you have, and then how to create a simple project. So because I'm on a Mac, I'm going to use brew. So within my terminal, I'm going to say brew install and then Maven. So this should take a while now. And there we go. So now we have Maven. Now, if you want to make sure that Maven was successfully installed, just clear the screen and then type mvn -- and then version. And there we go. So this is the version which was installed in my machine. So now that we have Maven installed, in here in this guide, you can see that we have this command that we can use to create a project. So we say mvn archetype generate, and then we pass a couple of flags in here. So here the group ID, so this is basically our organization, and the artifact ID is the application name. And then we pass some other arguments. So copy this command and then change this according to your organization or your name, and this as well. And I already have done that, so I'm just going to paste it. There we go. And you can see that the group ID is com.amigos code, and then the artifact ID is Amigo services. And in fact, before I run this, let me cd into desktop and then paste the command again. There we go. And just give a second. And there we go. So now in our desktop, you can see that uses Amigos code desktop. We have this folder right here. And what I'm going to do is cd to Amigos code services. And then in here, I'm going to say ls. And this is the Maven file structure. So let me see if I've got a tree in here. No. So I'm going to say brew install and then tree. There we go. And now I can type tree and check this out. So this gives me now the folder structure in a very nice way. So you can see that in here, we've got the root, we have the pom.xml, src main java com amigos code, app.java, and then the same for the test, and we are good to go. Next, let's open up this folder with IntelliJ. If you want to learn about IntelliJ, I do have a course on IntelliJ, and hopefully you did manage to enroll for a heavily discounted price. But if you haven't, I'm going to leave a link under the description of this video so that you can enroll and basically learn about IntelliJ. Now, IntelliJ, it's amazing, and you should be using it for your Java work. So I haven't seen people using like Eclipse or NetBeans, and if you do, please stop and switch to IntelliJ, because it's the one that most professional software engineers use across all the big tech companies. Now, IntelliJ can be quite intimidating, but don't worry, I've simplified the entire process, and I've got a course which is about 5 hours long, teaching you all the ins and outs of IntelliJ. Because if you know your IDE inside out, then you'll speed up your workflow, right? So it's having the tool and not knowing how to use it. What's the point, right? So you need to take full advantage of IntelliJ, the keyboard shortcuts, all the plugins, customization, database integration tools, Docker. Later on, we're going to learn about Docker. So it has pretty much everything. And the cool thing, which I love IntelliJ, is that you can just use it for your workflow. So i.e., if you are building backend, you can use IntelliJ. If you're using front-end, you can use IntelliJ. If you're doing DevOps, you can use IntelliJ. So one IDE for everything, and that way you could just focus on productivity, right? Instead of having to learn VS Code and then the keyboard shortcuts and then installing plugins on top of plugins, IntelliJ solves all of that. So go ahead and check the IntelliJ course if you haven't, and yeah, it's one that I recommend to my students, and it's quite popular, to be honest. So for now, catch me in the next one. So in here, I do have the IntelliJ Ultimate Edition, and if you want to grab it, I would recommend you to install JetBrains Toolbox. And if you want to grab it, I recommend you getting it through JetBrains Toolbox, because this is the easiest way that you can manage all of your IDEs and perform all the upgrades, so on and so forth. So here I've got the Ultimate, and this is what you see in here. Now let me open up this folder with IntelliJ. There we go. And inside of my desktop, I do have Amigo Services, which is this folder in here. So just pretty much just click on the pom.xml or the folder. Either one should work. Open as project, and just give it a second while it's downloading whatever it has to download. There we go. That's done. And what I want to show you is, so let me just put this full screen. So in here, if I go to file and then project structure, I just want to show you that I'm using Java 17. And in here, if you want to use Java 17 as well, so that everything works with no issues, just click on edit and then click on plus, and you can download the JDK. Just select 17. But in here, you can see that I can download all the other versions in here. So 16, 15, 13, 11, and 1.8. So 17 is basically the one which has the long-term support as I speak. So just use 17, and then that's it. Next, let's bring in the dependencies that we need in order to start building our microservices with Spring Boot. All right, so let me go ahead and open up this folder right here. And this is basically our parent project. So we're going to use Maven multi-module so that we can have dependencies, and then let all the submodules choose which dependencies that they need to import. And we can also enforce dependencies to all microservices. So in here, what I want to do is this folder src, we're not going to need it at this point because this is the parent module. And open up the pom.xml, and in here, so we have a couple of things, so just go through it, but basically change this according to your URL if it's not. So let me just delete that and leave the properties as is. And for dependencies, so inside of dependencies, let's just get rid of this dependency inside. So we're going to have our own dependencies in a second. And then for the build and then plugin management, so you can see that we have a bunch of plugins inside. So let's also just get rid of everything. And there we go. So let me just have the empty plugins, and there we go. Now inside, let me just have the empty plugins tag, and we're going to fill this in a second. Now, the dependency that we need in here is the following. So here I'm going to say dependency management, and then within have dependencies. And the dependency that I want in here is, so dependency, so the artifact ID. So this comes from Spring Boot dependencies, and this comes from org.springframework.boot, just like so. And then choose a version. So in my case, I'm going to pick the 257. So this version right here, I'm going to show you in a second, but this I think is the latest version as I speak. So make sure that you choose the exact same version so that you have no issues. Then what I also need is to say scope and then import. So this is using the BOM, where inside of this artifact, there's a bunch of dependencies that we can use. And this is because we're not using Spring Boot as the parent project. So this is our own parent module. And then we have submodules that can use basically these dependencies inside. So if they need, for example, the Spring Boot starter web, they can just include it right here. So this is the beauty of having the dependency management. Whereas if we have dependencies in here, so dependencies, so in here, let's say that we want every single submodule to have the Lombok dependency. So here, just say Lombok, and this comes from org.project Lombok. And let's also make sure that all submodules, they have the testing artifact from Spring Boot. So here, I'm going to say Spring Boot dash starter and then test. And this comes from org spring framework.boot. And there we go. So let me just put this full screen. Now, finally, because we are using Spring Boot, let's have the plugin for building the artifacts. So here, let's have a plugin, and the group ID will be com.springboot.springframework and then .boot. And then the artifact ID will be Spring Boot Maven, just like that. And also let's specify the version in here. So version, and this will come from the property. So this will be spring.boot.maven.plugin.version. And if you grab all of this and then scroll up, and inside where we have the properties, let's just paste that and then close that. And then basically what I want is to say 2.7 in here, but I just realized that this version right here is the exact same thing. So let's just take this from here and then say Spring Boot .dependencies and then version. And we can take this from here and then put it here, close that. And then inside we can say 2.5.7. And if you want, you can basically control these independently. So the Spring Boot Maven plugin as well has the exact same version. And you can see that this now is taking shape. So this should be HTTPS, and also this should be Java 17. There we go. And yeah, so this is now taking shape. So let's just basically reload the changes, and it looks like that we have an error. Oh no, that went away. But basically, if I open up Maven, so this still red. So if I clean, you can see that the process terminated. So let's have a look. So it looks like that I'm missing the type inside of the dependency management. So that's fine. So inside in here, I'm missing the type. That's for sure. And I want this to be POM. So this is so that we can use all these dependencies for our sub projects. Now let's reload. There we go. So all good. And you can see that we have the dependencies right here. Everything has been resolved. If I open up dependencies, we have Lombok and start a test. So this is what we have included, right, for our sub projects. We also have plugins. And in here, let's now clean. So I just want to make sure that this runs. And there we go. So let's validate as well. And also works. So we haven't got anything to compile, but you can see that this is working. So obviously, if you want to grab this file, you can grab it under the description of this video so that you can follow along. And all you have to do is just change the URL, the name, the group ID, and the artifact, and off you go. Now, just to recap, so we have some properties, but really dependency management. So this is so that our sub-projects can pick whatever dependency that they want, and you'll see this in a second. And then dependencies, this is so that all submodules by default have these two dependencies without them explicitly imported in their pom.xml. And then we have the exact same thing for the build. So build management right here. And basically not everything will be, and basically not everything will need this Spring Boot Maven plugin, and that's why it's inside of this plugin management. If you have any questions, drop me a message. Otherwise, let's move on. Let's begin this course by building our very first microservice. This microservice will be responsible for handling customer registration. And we're going to name this microservice as customer. Some people usually, they like to call their microservices as customer and then service. But I'm just going to drop the service all completely, and I'm just going to use customer. So we'll build customer first, then add an API, connect to its own database, and then we'll proceed to the next microservice and then make those two microservices talk to each other. By the end, you should have a complete understanding on how to pull all of this together. Now, how exactly are we going to achieve this? If you've been following my courses on Spring Boot, then you should know by now that Spring Boot makes it super easy for you to build Java applications. So in here, in the official page of spring.io, you can see that basically what you can do with Spring. You can write microservices, reactive programming with asynchronous, cloud, web apps, serverless, event-driven, batch, so on and so forth. So you can go and basically see how to get an application up and running super easy with Spring Boot. But in this course, you learn all of this. And what I want to show you is, so right here, because we are learning about microservices, let's just see what they have to offer. So in here, microservice architecture are the new normal, building small, self-contained, ready to run applications that can bring great flexibility and added resilience to your code. So basically, you can read more about this just to have an overview. But in a nutshell, in here, the way that we build microservices in the Spring world is using Spring Cloud. So this diagram right here is the representation of this diagram right here. And basically, I've put everything together because I want to build a fully fledged system that communicates to each other with their own databases, so on and so forth. And this diagram here is much easier for you to understand what is happening. But basically, at the end of this course, you'll have an understanding of all of this. But what I want to show you is, if you click on Spring Cloud in here, so they give you, again, definition. So developing distributed systems can be challenging. And this is what the Spring Cloud project gives you. So here you can see that we have projects, we have Spring Boot, the framework, cloud, data, so on and so forth, as well as security, which I have a course on it. But right here, so again, the exact same architecture. You can see that we have service discovery, API gateway, cloud configuration, circuit breakers, tracing, testing, so on and so forth. And what I want to show you actually, if I click on projects, let's go to Spring Cloud, and right here, have a look. So this is all the sub projects within Spring Cloud. Now, obviously, we're not going to use everything in here because, as I said, you should only really take what is necessary for you to write your own microservices. And then as we move towards Kubernetes, you'll see that some of these things are not needed. But go ahead and basically have some reading on how to get all of this up and running. But later you'll see that how we're going to install Spring Cloud, so on and so forth. I'll make it super easy for you to understand with Maven multi-modules. So hopefully now you know about Spring Cloud, and within projects, you can see that we have Spring Boot. So this is what allows us to write the microservices, and then Spring Cloud allows us to bring all these microservices together. And also you've got Spring Data for databases, Spring Security for securing your microservices, so on and so forth. If you have any questions, drop me a message. Otherwise, let's start developing microservices. Now that we have this pom.xml right here, and this is the parent pom, let's go ahead and create our very first microservice as a sub module. So in here, what I want you to do is right click in this folder right here, and this is the root, so Amigos services or whatever you have named it. Right click, new, and then module. Now at this point, so this will be a Maven project. The project SDK will be Java 17, and don't tick anything, just say next. And right here, you pretty much name the microservice. So in my case, I'm going to name it as customer. So this will be a microservice that will deal with customers. And if I expand the artifact coordinates in here, so the group ID will be com.amigos code, and then the artifact ID is customer, and then leave the version as is. Finish. And there we go. So now have a look. So we have this new folder right here. This is customer, and inside, so let's just open up the parent pom, And what I want you to notice is that we have now by default this new section in here, so modules, and this is a list of modules. So we can only have one module right here, and this is customer. Now, if I open up customer, so this will again have the exact same folder structure. So for any Maven project, so you have the pom.xml. So inside of this pom.xml, we have some properties, and basically have a look. The parent, you can see that we have this icon. So this goes to artifact amigos code services right here. And I usually like to flip these around just like that. And then the model version. And then this is the artifact for this project right here, which is customer. And if I open up src main, so this is basically everything is empty, and we're going to add a few things in a second. But for now, what we're going to do is let's just open up the pom.xml for our customer microservice, and let me close this for a second. And what I want to do is inside in here, let's have, so we're going to say basically we want to have the dependencies right here, and now we can bring any dependency that we want. So for now, all I want to bring is, so I'm going to say dependency, and this has the artifact ID as spring boot dash starter dash and then web, or starter dash and then web, just like that. And this comes from org.springframework.boot. There we go. So now, so in here, have a look. So you can see that this dependency right here, it comes from, so if I click on this button in here, it comes from Spring Boot dependencies.pom, so 257. So this is what we have defined in here. Have a look. So right here, so dependency management right here, we brought all of these dependencies, and now we are letting each of these microservices choose whatever dependency that they want to use. So for this microservice, we want to be able to write a RESTful API. So hence we are bringing in this dependency. At this point, this is all we need. So what we're going to do now is, let me just close this POM and also this main POM. Oh, actually I closed the wrong one. So let me just open the POM for customer. Now inside of src, so inside of customer, src main Java, let's create a new package, name it as com.amigoscode dot and then customer, just like that. And what I want to do is I want to basically create a new Java class, and then I'm going to say customer application, and this will have a main method, and this class we're going to annotate it with add and then spring boot application, and here I'm going to say spring and then application dot run, and the primary source will be customer application dot class. There we go. And also we need to pass the arguments from the command line. And this is pretty much what we need. So we also need to have the application.yaml inside of resources. So here, file, and then say application.yaml, or if you prefer properties, it's completely up to you. Enter. And inside, I'm going to have server, and then I want to have the port. So I want to have control of the port, just like that. So the default is 8080. So let's say that we want this to be 8080. And we also want to name this application. So Spring application name, and this will be customer. There we go. Now, what I want to do is I want to basically create a new file in here, and I'm going to name this as banner.txt, and open up Google and search for create Spring Boot banner, and click on this very first link. And in here, let's just say customer, and you can change the font if you want, but I'm just going to leave the default. Copy everything, go back, paste that in, And last but not least, what I want you to do is open up the pom.xml, and you should see this Maven button right here, or you can press Shift Command O to load the Maven changes. So we've added this dependency. So let's just make sure that this is reflected in this microservice. So if I open up, so right here we've got customer, and the only dependencies that customer has is Lombok and start a test. And this is because, so if you recall correctly, inside of dependencies, we said that we want all the microservices or all these submodules to have these two dependencies, right? But we included this one right here for this module, but it's not showing up in here because I need to reload in here. So you can reload from here or from here, either one, and you can see that you now have the dependency, and it's just taking a while to index. And there we go. Now let's open up the customer application. So this is our main method, and right click, run. And there we go. So you can see that. So let me show you the logs. Have a look. So we've got our custom banner in here, which is customer, and you can see that everything started correctly. And you can see that Tomcat started on port 8080. So there we have it. We have our first microservice. Currently, it doesn't do anything. It doesn't talk to any database, so on and so forth, but we'll add that in a second. But you see how easy it was for us to bootstrap a microservice with Spring Boot. So within this package right here, com.amigoscode.customer, let's go ahead and create the model for this microservice. So this will be customer. So this is a class, and in here I'm going to use Lombok. So every submodule has Lombok in it. So here I'm going to say add, and then data. So this is Lombok, and then add, and then I'll also need the builder in here. And there we go. So we're going to come back to this class in a second, but for now, this is all we need. Now here, let's have a couple of fields. So let's have the ID as an integer. Let's also have the first name and last name as a string. And finally, let's have the email in here. There we go. Now what we're going to do is, so we've got the model. So basically we're just following the n-tier architecture, and I've got a bunch of videos covering all of this stuff, how to properly organize your application, so on and so forth. So here, let's start from the controller. So I'm going to say customer and then controller. So this will be at and then rest controller. This will also need the at request mapping, and we're going to map this to API/v1/ and then customers. And I also want to have the at SLA for J, just like that. So I can just log a couple of things. And I've just realized instead of a class, let's just use a record. And because inside we're going to pass a couple of things in a second, so just leave it like that. And now let's have a public method that will basically take a customer from the request body and then register a customer. So public void register customer. This will take a customer request, and we're going to create this in a second. There we go. And this customer request will come from the request body. So at request and then body. Let's log the customer request. So log dot and then info. So new customer registration, and inside we're going to pass the customer registration, just like so. And we also need to annotate this with at and then post and then mapping, so that we can fire post requests against this endpoint in here. Now let's create this class quickly. So here, new and then Java class. This will be a record, and let's just say customer registration and then request. There we go. And what we want to pass in here is the first name. We also need the last name, and finally the email. There we go. So this is our record, and the reason why I'm using a record and not a class is because I get immutability, to strings, equals, and all that stuff for free. Whereas in here, I'm actually going to use JPA in a second. Now, inside of my customer controller, so this should be actually customer registration request, just like that. Delete this, and then let's just log that instead in here, and job done. So there we go. And now let's create the service that will basically handle this request. So let's just say customer, and then service, customer service, and this customer service. So let's just create this class. So create class. There we go. And let's also change this to a record and pass nothing inside for now. And if I go back in here, so what I want to do is just say customer service dot, and then register customer, and then pass the customer registration request, just like that. And I need to create this method in here. So there we go. And voila. So I've got the request in here. Now let's turn this request into the customer. So here I'm going to say customer equals to, and then customer dot builder. We're going to pass the first name from the request. We also need a last name, and finally email. And all we need to do is just say build. So this is the builder pattern, and there we go. Now let me just say to do here, and we're going to do this in a second. So there you have it. So basically right here, you can see that how the application is taking shape. And what we have to do next is just get the database up and running, and then configure our application so that we can store the customer to our database. And finally, we need to annotate this class with @service so that Spring initializes this as a bean for us so that we can inject it in our controller. Let's go ahead and get our database up and running so that we can connect our microservice to it. So in here, what I want you to do is under the root folder of microservices right here, so Amigos services, actually go ahead and say new, and then file, name this as docker -compose dot, and then YAML, and then press enter. Now inside, I'm going to paste some YAML configuration, which you can find under the description of this video. And if you want to learn more about Docker, go ahead and check my website. I've got a course teaching you everything you need to know about Docker. But in a nutshell, so let's just start from the top. We've got services. This is Postgres. And then this is my container right here. The image is Postgres. I'm exposing the ports. And then this is the network. And right here, I've got pgadmin. So this is the graphical user interface client. So I'm giving the name and then passing some environment variables to connect to it, and exposing the port 5050 to 80 inside of the container. And right here, I've got the networks so that they can talk to each other, and then some volumes to store some data. So once you have this file, and make sure it's named as docker-compose.yaml. So you can actually run this from here if you have the Ultimate Edition, and if not, I'm going to show you how to run it through the terminal. So in here, open up your terminal or command line, and make sure that you are within the project. So I'm going to type ls, and you can see that I do have this docker-compose.yaml. Now to get things up and running, just type docker space and then compose, and then up, and then -d for detach. Press enter, and you can see that it's creating the network. And now it's creating the containers, so the pgadmin as well as the database. And there we go. So you can see that this was super quick. You can type docker compose and then ps, and you can see that we do have pgadmin, which is listening on port 5050, and the Postgres, which is listening on port 5432. So now that we have this database, let's connect to it. So open up your web browser, and in here type localhost and then 5050. Press enter. Just give it a second, And there we go. So you can see that, oops, the font is too big. So now we need to set a master password. So I'm just going to say password. Right, so now let's basically add a new server. And in here, I'm going to basically name this as Amigos Code. And the connection, so in here, the host, this will be Postgres. And this is because we're connecting from a container to another container right here. So if I show you inside of services, have a look, networks, Postgres in here. So this guy right here uses the exact same Postgres, or the exact same network, which is Postgres. So pgadmin uses Postgres, and right here, this is how we define the network so that these two containers can talk to each other. And if pgadmin wasn't running with Docker, you would need to say local and then host. So this is Postgres, the port is 5432, leave the database maintenance, the username, so this is Amigos Code, and the password is password. There we go. I can save the password. And to be honest, this is it. So click on save, and you can see that we managed to connect to our database. So I can click on it, and you can see that there is not much information in here, but basically if I expand in here, you can see that we have databases, and by default we have Amigos Code and Postgres. So now we have a database that we can work with. Next, let's configure our microservice to connect to it. So within IntelliJ, what I want to do is, let me just close all of these tabs. So close all tabs, and let's start fresh. So inside of our customer microservice, open up application.yaml. And in here, what I'm going to do is paste this configuration, and you can find this under the description of this video. And also, if you want to learn more about Spring Data JPA, you can check my website where I've got a course on this, teaching you everything you need to know about connecting to databases, joins, how to model your table, queries, so on and so forth. So it's a very in-depth course, which you should take. So in here, what I have is the data source key right here. And within it, I do have the username. So this is Amigos Code, and the URL, this is PostgreSQL localhost right here. And the reason why it's localhost is because our application right here, when we start, it's not a container. If it was a container, then we would need to connect via the network. But in here, you can see we also have the port and customer. So I'm going to come back to this in a second. We've got the password, which is password. And then here we have some configuration to set the dialect, format SQL, update when we update our entities, and then show some SQL. Now this customer right here, so this is the name of the database that we have to connect to. So if I go back to pgadmin, inside of databases, create database, and then the owner is Amigos Code, and here let's just say customer. I'm going to say save, and there we go. So now we have this database that we can connect to it. Now, the last thing that we have to do is to open up the pom.xml, and in here we brought this dependency, so start a web. So this is for RESTful APIs, but we also want the dependency that allows us to perform queries and interact with our database. So in here, let me just put this full screen, and this is Spring, and then boot, and then starter, and then JPA or data JPA. There we go. And what we also need to bring in is the Postgres driver. So dependency, and this will be PostgreSQL, and this is from org.postgresql, and you can see that this is coming from the parent POM. And in here, I'm going to say that the scope for this is runtime. There we go. Now go ahead and basically reload. So the changes are picked up. If I open up Maven in a second, you should see that we now have data JPA in here, as well as the PostgreSQL driver. So all good. Now let's open up the customer class, and in here we need a couple of things. So one, we need the at and then entity annotation, and also we need at all args constructor, and also no arg constructor in here. We're not done yet, so we need to annotate this with at and then ID, and the ID will be based off a sequence. So let's just have the sequence generator and then import sequence generator. And finally, we need to have the generated value, just like so. And let's import the generated value as well as the type. So I think at this point is trying to basically have a star. So here, let me just say type. So generation type, and we are good to go. So with this in place, let's now create a new interface. So this will be customer repository. This will extend, and then JPA repository, where the entity is customer and the data type for the ID is an integer. Now what we need to do is open up the customer service, and inside of this record we're going to inject it, so customer repository, so that we can basically save our customer. And for this to do right here, store customer in DB, let's just say the repository, so repository dot and then save and then our customer. Job done, and delete this to do. Obviously there are more checks that we have to do, but for now, this should basically save customers in our database. Now let's start the application, and hopefully this works. And there we go. You can see that we have some logging, and here create table. So ID, email, first name, last name, and then the key is the primary key is the ID, and we also have the sequence. So this is good stuff. So now what I want you to do is to open up pgadmin, and within Amigos Code databases, customer, and then open up schemas. So we have one schema, and this is the public schema. Open that up, and then we should have one table inside. And in fact, let me just refresh. There we go. And now if I open up tables, have a look, we have the customer table in here, and also the sequence, which is right here. So customer ID sequence. So this is really cool. So if you want, you can basically count the number of rows. So this will give you 0. So there is nothing inside, and you can even basically run queries against this. So you could say, for example, select star from and then customer, and then run this, and you can see that this gives us back. But you can see that we actually are connected to our database, and we have a table called customer based off our entity. Now what I want to do is send a post request into my API and see whether we can save a customer. So I'm going to use Postman as my REST client, and you can use any other. So in here within Postman, new request to, so this will be a post, and the URL will be localhost, and then 8080 v1 customers, select body, raw, from text to JSON, and in the body, let's have this JSON blob. So first name, last name, email, Jamila Ahmed, J Ahmed, and this JSON object right here corresponds to, so if I go back in here, so corresponds to this guy here. So if I open up the customer registration request, so it maps to this record, first name, last name, and email. So if I go back, and then let's try and send the request and see whether it works. So send, there we go, 200 status code, which means that we most likely have saved this customer to our database. So here I'm just going to rerun the exact same query and have a look. So now we have Jamila Ahmed in here. So this is beautiful, and you can see that how we now have our microservice connected to its own database. in this course, I'm not going to focus a lot on the database part, so all the queries and whatnot, because I do have an extensive course on Spring Data JPA, and it teaches you everything you need to know in order to build applications that connect to a relational database. So Spring Data JPA, it's amazing for building microservices because it abstracts all of the things that you really don't need to know. So all the queries and the setup and whatnot, and it makes it super easy for us to focus on what we want, which is building our business logic. If you're interested in the course, go ahead and check the Spring Data JPA. I'm going to leave the link under the description of this video so you can enroll and learn about databases. Also, if you're interested in SQL and you're not really too sure about databases, relational databases, queries, joins, indexes, transactions, and all of that stuff, I also have a course focusing on databases. So I'm going to leave both those links under the description of this video. So if you need to brush up on those areas, you can. So we've managed to build customer. Now let's build a second microservice. And the idea with this microservice is that in order for a customer or a person to be a customer in our system, we're going to perform a fraud check. So we'll have a second microservice, and this microservice responsibility is just to perform fraud checks, i.e. if the customer is fraudulent. And obviously we're not going to use an external provider for checking whether someone is fraudster or not, and instead we're going to mock things by pretty much just returning true. But you'll see that how we basically handle the responsibility to a second microservice, which is only focused on the fraud knowledge, right? So if the fraud microservice, or if the fraud knowledge increases, then it's actually independent from the customer microservice. So you can have one team which is focusing on the customer side of things, and then you've got another team which is focusing on the fraud aspects of your application. So let's kick off this section. So within IntelliJ, let's create a new module, and this will be the fraud module. So this will be a Maven project, and then next, and this will be fraud right here. So this will represent the fraud microservice, and leave everything as is. Then finish. And let me just say, don't ask. So I'll be pushing this to Git in a second. So cancel. And here we have our fraud module. Now let's add the dependencies within our POM. So inside of our POM, what we need is a dependencies section. So here, dependencies. And then inside, for now, let's just have the Spring Boot Starter Web. And let me just close this. There we go. And within SRC, and by the way, you can see that this is already configured. So the parent is Amigo services right here. And you can see that we can navigate to the parent POM. And within the parent POM, we have this module inside of modules already added for us. So let me go back to this POM. So this now is looking good. We're going to add the database dependencies in a second, but now within main Java, let's create a new package. This will be com.amigoscode and then fraud. There we go. And let's have the fraud application. So this will be our main class. There you go. Now let's annotate this with add, and then Spring, and then boot application. And within we have to have the main. And now let's just say Spring application.run. We pass fraud application.class inside. And also we pass the arguments. And to be honest, this is it. So let's just make sure that this is configured correctly. Now, always when you add something to your POM, so in here, always reload so that you can pick up the dependencies. So if I click on Maven and then go to, we should see fraud in here. So if I expand this dependencies, you can see that starter web is not in here. Now you can reload from here or from here. So either one will work. So reload, and you should see that we have the starter web. If I close this, now within fraud application, I can pretty much just run the application. And there we go. So you can see that it is running. Now, one thing that we have to configure is the port. So Tomcat started on port 8080. Now, if you have customer, so the customer microservice up and running, this will fail because customer is using this port. So let's just configure that. So here, within resources, we need the application.yaml. So file application.yaml. And then let me go to customer, and within source, and then main resources, let's take the application.yaml and let's copy all of this. So I'm going to paste this here, or actually not there, but in here, paste that, and let's use 8081. And then for the application name, this will be fraud. There we go. And we also need the banner.txt. And you can go to that website to generate a banner like this. So this now says fraud, and we are good to go. Now, if I restart the application, there we go. You can see that it started correctly. It's running on port 8081. Let me also start customer just to make sure that customer starts correctly. So within the customer package, open up the customer application and then run. And there we go. So you can see that we have customer up and running as well. Now let me just stop customer because we're not going to develop anything for now. But you can see that we successfully managed to have a second microservice up and running. Next, let's add the database to this microservice. In a typical microservice architecture, you kind of want to have one database per microservice. Now, because I'm running out of resources and I'm using the Mac M1, and if I basically have a bunch of containers for different database servers or instances, then I'm going to run out of space very soon. So what I'm going to do is within our main server, so Amigos code, let's have yet another database inside. So we have customer. So let's also create the fraud database. So save. And basically what I'm saying is, so within our Docker Compose in here, you can see that we have services, and this is Postgres. And basically what I'm saying is we would need basically to have another service for fraud, right? But so this you'd say, for example, Postgres and then fraud. But because I'm going to run out of resources in my computer, so I'm just going to reuse the exact same database instance and have a database inside. But ideally, again, in a microservice architecture, you want to have the database servers independently. Now let's add the configuration. So I'm going to copy from the customer microservice in here. So let's just copy the data source. So all of this will be the exact same thing. So application.yaml, and then paste that in. And I need to indent this a little bit. Now this is a valid configuration. And now instead of customer, this will be fraud, because now we have the fraud database in here, and the username will be Amigos code, and the password will also be password. But as I said, so this usually would be a different database, but in our case, we're just reusing the exact same instance, and then within it, we have the fraud database. So now let's open up the pom.xml for fraud. And we need to add the Spring Data JPA as well as the Postgres driver in here. So make sure that you have these two dependencies the same way that we've done for customer. And now what we're going to do is within our main package, let's create a new Java class. and we're going to name this as fraud check history. And within it, we need the data, builder, all R constructors, and no R constructors. And make sure to import all of these. And we also need the entity. So this is for JPA. And within it, let's have the ID. So the ID will be the same way that we've done with customer, but we're going to have the sequence for fraud instead. So and then ID. Let's have the sequence generator. Make sure that this is for fraud. So here, make sure that the name is fraud ID sequence and fraud ID sequence for the sequence name. Let's also have the generated value, and let's import this. The same for type. And last but not least, we need the ID. So private integer and then ID. Let's also have the customer ID, just like that. I also want to have a Boolean just to make sure that we store the result whether the customer is a fraudster or not. So is fraudster. And finally, I want to record when this check took place. So local and then date time and created and then at. And to be honest, this is it. Now what we have to do is restart the fraud microservice and just make sure that everything works. There we go. You can see that we have create table and we also have the sequence. If I open up PG admin and in here, refresh, and then if I go to schemas, public, we should have one sequence, fraud ID sequence, as well as one table with all these 4 columns. Next, let's go ahead and build the controller, service, as well as the repository. So we have the entity set up. Let's have the repository for it. So this will be an interface in here. And we're going to name this as fraud check history repository. Press enter. And let me put this full screen. This extends JPA repository. This is check history or fraud check history, and then integer. Oops, not that, but integer, just like that. And let me put it like that. And now let's have the controller. So here, or let's have the service. So I'm going to basically fraud check and then service. So in here, let's just have a class, and then I want to name this as service. And this time I think let's not use records because I don't want to confuse you guys. So I'm going to change the customer as well to use a normal class, because I think it's easier for anyone to understand whether you're not using the latest version of Java or not. But in here, what we want to do is just to perform a check for a particular customer. So here I'm going to say public and then Boolean is fraudulent and then customer. And we're going to take the customer ID. So integer customer ID, just like that. And in here, so what we're going to do is basically, for now, we're going to make sure that everybody, it's not a fraudster. So I'm just going to return false. So let's just return false. But obviously, if you were doing this for real, maybe you would use a third-party system, or you could have your own system that checks whether a customer is a fraudster or not, maybe checking their email against so on and so forth, and all kind of things that you can do. But in our case, we're just going to return false in here, but also we want to store the fact that there was a check that took place. So private, final, and then fraud. And then we want the history repository, just like that. And then add to a constructor parameter. And there we go. Now, obviously, I want to basically store the fact that this took place, dot, and then save. And then inside, I'm going to say fraud check history, dot, and then builder. And in between, so before I build, I want to set a couple of things. I want to set set is fraudster. I'm going to say false in here, and dot. Let's also set the customer ID. So this will be customer ID. And finally, I want to set when this took place. So created at. This will be local date now, just like that. And then we build, and then we basically store this in our database. And we are storing the fact that a check took place. Now here, let's annotate this with add and then service. There we go. And let's also have the controller. So class, and then I'm going to say fraud controller. This will have at rest controller, at request mapping. This will be API /v1 / and then fraud and then dash check. There we go. And this will be a post and then mapping. And here we're going to say public, and the return type will be a fraud check response. So I'm going to say fraud and then check response is fraudster. And let's just create this. So this will be a record. So create record, and inside I'm going to say is and then fraudster, and this will be type boolean. So this is all I need. Then if you want to include more things in it, then you can. Now for this post mapping, all I need is to receive the customer ID. So here, this will be a path variable or a path in here. And I'm going to say this as customer ID, just like that. And if I put this full screen, we say this will be a path at and then path and then variable. This will be customer ID. The type is integer, customer ID. And let me just put this like that. And now I can have the service. So private fraud and then check service. There we go. And make sure that this is final and add this to constructor. There we go. And now all I need to do is just say fraud check service and then is fraud, pass the customer ID. And all I'm going to do is extract this to a variable. And I want to say is fraudulent customer. Put this on a new line so you can see everything properly. Now I'm going to say return new fraud check response and then pass is and then fraudulent customer. And I've just realized that this must be a get mapping instead of a post mapping, and import that. And also, instead of us doing all of these shenanigans, what we're going to do is basically having private final and then the constructor in here. I kind of forgot that we have Lombok, so let's just in here. And if I go back for a second, so we just have to delete the constructor, and in here we can say at and then all our constructor, and you can see the error goes away. Let's just do this for basically everything. So the check service, so we'll delete the constructor in here and we pass the annotation, so at all our constructor. Let's take this and let's do the same for customer. So customer service, so we'll change this from the record to a regular class. And in here, let's just take this from here, private final customer repository, and stick the annotation in there. Beautiful stuff. Let's also do it for the controller. So annotation in there, take this guy, change it to a class instead, and then private, paste that in, and let's make this final. So the records gives us a bunch of things that we don't need for our services, and I think this is much better. Okie dokie. So now that we have this fraud controller, next let's understand how the communication between microservices will work. So we have customer, which is running on port 8080, and we have fraud, which is running on port 8081. Now we want this microservice to send a request to this other microservice called fraud to check whether a particular customer which is being registered is a fraudster. Now, there are multiple ways that we can achieve this. One is to use REST template, which I'm going to show you first, and then I'm going to show you how to add service discovery so that we can eliminate the use of the ports. And then I'm going to show you also how to use OpenFA, which is my favorite way. Now, let's go back to IntelliJ. And within our customer microservice, open up customer service. And in here, remember, we had this method register customer, and we have a couple of to-dos. But basically, what we want is to have this to-do where, so to-do, check if fraudster. And also what I want to do is, so another to-do here, I want to basically send notification. Now, obviously, we now have the ability to check whether a customer is a fraudster. So in order for us to send a HTTP request to fraud microservice, let's have a class in here called customer config. Let's annotate this with add configuration. Inside, let's have a public method. This will return a REST and then template. And then in here, I'm going to return new and then REST template. Now, obviously, we can configure the REST template, but at this point, we're not going to, because I'm going to show you a better way of doing this. Now, obviously, we need to annotate this with @bin, and off we go. Now, within our service, we can inject this by just saying private final REST template, and there we go. Now, inside in here, so line 22, we can complete this to do. So here we're going to say REST template dot and then query get for object, and inside we're going to pass a couple of things. So one is the URL, so this will be http://localhost:/, and then the port which the fraud microservice is running is 8081, and then /API/v1 / and if you don't remember, inside of the fraud controller we have fraud and then check. So here fraud check, and also we have to pass, so / and then customer ID, and then curly brackets, and then customer and then ID, just like that. And then here I'm going to say comma, and then we need to pass the response type. So at this point, let's just basically, so in here, fraud check response, we're going to copy this. So let's copy this, and I'll show you a better way of doing this, right? So here, let's just copy this class. So fraud check response, and then within our service, we can say that this will be a fraud check response.class, comma, and now we need to pass the ID. So basically in here, you can see that we registered the customer after. So let's change this for a second. And what we want to do is we want to save the customer at this point. And in here, I'm going to say save and flush so that we can have access to the customer ID. And now on the entity, so if I don't say save and flush, then the ID will be null. So here we are saving and then flushing. And if you want to learn more about the entity lifecycle, go ahead and check my Spring Data JPA course. So now customer dot and then get ID. And there we go. And now I'm going to extract this to a variable. And this is the response right here. So I'm going to name this to fraud check response. And then if the fraud check response dot is fraudster, so if it is fraudster, we basically want to throw maybe a new illegal, and maybe you want to have your own exceptions, but here I'm just going to say state exception for now, and then I'm just going to say fraudster, and also you can have a better message just like that. And we have to check for null pointer exception as well, so you can assert in here. But at this point right here, so we save and flush the customer, and perhaps we could have some other logic just to make sure that the same customer is not trying to register with the same email, so on and so forth, right? But you can see this is why we have these checks. And also I can see that I'm missing // so http :// localhost :8081. So there we have it. Next, let's go ahead and test these changes. Okie dokie. Now let's go ahead and start the fraud microservice. And let's also start the customer microservice. So I'm going to start both. So fraud is up and running. Now customer, just give it a second. And there we go. So they are both up and running. Now what I'm going to do is let me open up Postman again in here. So I still have the Jamila payload, and I'm just going to send this request. So again, this is post to customer 8080 API v1 and then customers, send, and check this out. So we have a 200 status code. Now at this point, let me just open up PG admin, and in here let's basically check the customer database as well as fraud, just to make sure that the request did work. So in here, let me just refresh everything. So refresh and open up customer. So in here, right click and then open up query tool, and then say select star from and then customer. And if you run this query, have a look, we have Jamila Ahmed in here. So this is cool. And by the way, if you have duplicates, that's fine because I've deleted the previous record. Now here, let me open up the fraud database, right click, and then I'm going to say query tool on that as well. And here I'm going to say select star from, and then the table name was, so within schemas, so tables, we have fraud check history. So fraud check and then history. And then if I run this request in here, check this out. So it indeed worked. So this was the timestamp. This is the customer ID. You can see that this is one, which corresponds to this one, which is Jamila right here. And in here, so you can see that Jamila, she's not a fraudster. So there you have it. So you can see that we've managed to have our microservices talk to each other. Now, one thing that I want to do is just to add some logging. So inside of fraud controller in here, I'm going to add @ and then s la4j, and then I'm going to say log dot and then info, and here I'm going to say fraud check request for customer, and then in here I'm going to pass the customer ID. So there we go. So I just want some logging so that I don't have to check the databases that often. And let's make sure that we have one on customer as well. So customer controller, and indeed we have the logging in here. So far you've seen that customer talks to fraud microservice on port 8081 via HTTP. Now in here we only have one instance of customer and one instance of fraud. But what about if fraud gets too busy and we have to bring up a second instance? Now you can see that customer can talk to fraud via this port 8081, but also via this port, which is 8085. Now, in order for this to be possible, customer would need to know all the existing ports for fraud. Now, you can see that this is a problem. If fraud scales to, let's say, 10 instances, then customer needs to know about all of those 10 instances, i.e. all of their ports and where they are running. And this is when service registry comes to rescue. And in this course, we're going to kick off with Eureka Service Discovery, but later as we move to Kubernetes, you will see that we won't need Eureka Server at all, but still good practice for you to fully understand how it works. So service discovery is the process of automatically detecting devices and services on a network. So on this side, we have our microservices. So because we are using Eureka, we're going to refer as the Eureka clients. And then we also have the server itself. Now, the server, this is where the clients will register themselves. So when they register, the server will know the exact information where the service is running, i.e. the host as well as the port. Then the microservices as well, whenever they need to talk to another microservice, they will basically look up to this server as well. And this is how they can connect with each other. So the server knows all the client applications running on each port and IP address. And now let me demonstrate to you how it works if we were to have two instances of fraud. So before I said that customer would need to know all the ports for fraud, i.e. 80, 81, as well as 80, 82 or 80, 85, right? Now, customer, the first thing that it does, registers itself as a client to the Eureka server. The same with fraud. So this instance of fraud, as well as this instance of fraud. So now this server right here has information about the IP addresses as well as the ports for all microservices. Then if customer wants to talk to fraud, let's say through HTTP, the first thing that it does, it sends a service discovery request, i.e. where does fraud lives. Then the server in here will return the address for one of these services, i.e. this one right here or this one running on port 8082. And then off it goes the request to, for example, let's say this instance of fraud. So this is how it works. Now you can see that in here we have a bottleneck. So this Eureka server, if for whatever reason it goes down, so if this goes down, then you can see that how all of these microservices are meant to talk to each other. So this is why it's very important that we do our best to keep this server up and running at all costs. But later, as you'll see when we move to Kubernetes, we won't need to use this Eureka server, which will be one less pet for us to worry about. Next, let's go ahead and install the Spring Cloud dependency in order for us to set all of this up. Within spring.io, navigate to projects and then select Spring Cloud in here. And basically Spring Cloud provides tools for developers to quickly build some of the common patterns in distributed systems. For example, configuration management, service discovery, circuit breakers, routing, microproxy, control bus, one-time tokens, so on and so forth. So on the left hand side, you can see what they have to offer. So a bunch of things, so including Kubernetes, GCP, Cloud Functions, OpenFace, security, Sleuth, which you'll see in a second, Vault for secrets management. And right here, you can also read more about, what they have to offer. But basically, and also load balancing, which I'll show you how to use this in a second. So in order for us to take advantage of these features, we have to install Spring Cloud. Now in this page, if I scroll down, you can see that this is how we install it. So we just include it in our dependency management and we refer to the version and then type POM, scope import, and then job done. Now, if I also scroll down in here, so what I want to show you is, so let's see if they have the current version. So actually, I think it was right in here. Yes. So right in here. So as I speak, this is the current version right here. So the release train. So you can see that this Dalston was for the boot version 1.5. And then as it went all the way to 2.4, this is the version that you should be using. So 2020.0 dot and then X in here, and then AKA Ilford. So you can click on this link and you'll see where it takes you. But basically, you can see that here are all the releases. So currently it's at 2020.0.3, and you can read more about these release notes in here. But as I speak, I'm going to install 2020.0.3. And for you to follow along so that everything works without no issues, please do install this exact same version. So if I go back in here And right here, what I'm going to do is I'm just going to basically take this dependency in here, Control C, and then let's open up IntelliJ, and within it, open up the main POM. And what we're going to do is, so if I put this full screen right here, so within the dependency management, we already have the Spring Boot dependencies, but let's also have this one right here for Spring Cloud. Now, this is so that we can let all these submodules pick whatever dependencies that they want, the same way that we've done with this Spring Boot dependencies. Now, obviously, we need to have this version in here. So Control C, and then in here, I'm going to basically have this version like so. And the version I said was 2020.0. and then 3. Now go ahead and reload so that it picks up the changes. And there you go. So now that we have Spring Cloud installed, next, let's go ahead and get up and running with Service Discovery. Okie dokie. Now that we have Spring Cloud, let's together build the service which will be responsible for our service discovery, and then we'll have both customer and fraud connect to it so that we can take advantage of service discovery and not worry about ports. So in here, let's go ahead and create a new module, and I'm going to name this as, so basically leave everything as is. This is a Maven project. Click on next, and this will be Eureka dash and then server. And now if I open up the main pom.xml in here, if I scroll up, you should see that we have the Eureka server module, and right here we have Eureka and then server. So here what we're going to do is let's just open the pom.xml, and within dependencies, so let's just have the dependencies block, and in here what we need is a dependency that comes from Spring and then Cloud, and the artifact is Spring dash and then Cloud dash starter and then Netflix, and then we have the Eureka and then server, and then this comes from org.springframework.cloud. There we go. If I put this full screen, I just want to show you what we have in here. Have a look. So this is the dependency that we have, and you can see that it comes from, if I click on this button, you can see that basically it's from Spring Cloud Netflix dependencies, and this is this dependency that we've just added right here. So this one is part of this. So now that we have the dependency, let's together open up the Java folder, create a new package. This will be com.amigoscode and then Eureka server, and inside let's just have the Eureka server application class, and let's annotate this with @spring boot application. Also inside let's have our main method, and then inside say spring application dot run Eureka server application dot class, and then pass the arguments. So you've seen all of this. Now for this class in here, we need to basically tell that this will be the Eureka server. So just annotate this with @ and then enable Eureka and then server. And right here, this is not picking up because I need to reload. So remember, we added a dependency, but we haven't reloaded the Maven changes. So this should work now. And there we go. So now you can see that I can import the class and job done. So one more thing that we have to do is to add the application.yaml. So file application.yaml. And in here, I want to basically have the server port. So server and then port. And this will run on 87 and then 61. We also want to define that. So there's a property called fetch registry. This will be equals to false. And then also in here, we need to say register with Eureka. So register with Eureka. So this will be false because this is our server in here. But you'll see that the clients will need basically fetch registry right here, which indicates whether this client should fetch the registry information from the Eureka server. No, this is the server itself. And then we have register with Eureka, indicates whether or not the instance should register its information with the server. Again, no, right? So the server, this is where the clients will register to it so that it can be discoverable by others. And one last thing that I forgot is to add the application name. So application name, and this will be Eureka dash and then server. And I usually like to put this at the very beginning, just like that. And there we go. So now let's open up the Eureka server application. Let's run this. And currently both fraud and customer are not running, but we'll get them up and running in a second. So I just want to make sure that this works. There we go. You can see that it's working. And right here, Tomcat started on port 8761 in here. So also, you can go and add the banner.txt if you don't want this default in here. So let me just collapse this in here and create the banner.txt. And then paste this. So I already had in my buffer, and you can go and generate this from the website I gave you before. So if I reload once more, we should see now our banner, and our Eureka server is pretty much ready to go. All right, so Tomcat started on port 8761. So let's go ahead and open up our web browser, and in here, I'm going to basically navigate to localhost and then 8761. So this is where the server is up and running, and then just press enter. Now have a look. So this is this web page right here, which says Spring Eureka, and it kind of gives me information about the server itself. So basically there's nothing about the environment, and this is because it hasn't been configured. But here you can see current uptime, renewals, the replicas, and more importantly, instances currently registered with Eureka, which are none. So no instances are connected. So this is the server itself, and we haven't told our microservices to connect to this Eureka server. So we haven't done that yet, and we're going to do that in a second. But also what I want to show you is there's basically some information that you can see: the total available memory, CPUs, the current memory usage, and then the instance information right here, and the status is up. So this is running on localhost, but basically this page doesn't give you much information. But as we start registering the clients, i.e. our microservices, to this Eureka server, we should see this section right here being updated, as well as the number of instances that we have registered per each microservice. Next, let's go ahead and configure our microservices to point to this Eureka server. So in here, I'm going to leave the Eureka server up and running, and let's start with the customer microservice. So pretty much open up customer main POM in here, so pom.xml, and inside what we're going to do is, remember for our Eureka server we added the Eureka server dependency. So let me just show you once more. So in here, so inside of this pom.xml, have a look, we have Spring Cloud Starter, Netflix Eureka server. So we kind of need the exact same thing in here, so copy that and then go to customer, and in here I'm going to paste this in. But instead of the server, what we need is, so in here, if I press Control Space, we have the client. And this again is from Spring Cloud. So now we're telling that this will be the client that will connect to our server. Now reload in here and then open up customer main, so the main class or the customer application, and let's annotate this with @ and then enable Eureka and then client. Now the other thing that we have to do is open up the application.yaml. So this is how we tell it where to connect to the Eureka server. So in here we need a couple of things. So right here after the database configuration, I'm going to say service and then URL, and inside we have the default and then zone, and this will be http://localhost 8761/Eureka. Now what we need is to do the exact same thing for fraud. But before we do that, let's start the custom application just to make sure that everything works. So just give you a second. And in the logs, we should see that in here, have a look. So started application and have a look. We have discovery client, customer, and this is the port right here. So I'll come back to this in a second, but you can see that the application started correctly. Now, if I collapse this and then open up my web browser, and in here before, remember we had no instances available. If I reload, have a look, we have customer in here. Now the concept is really simple. So we have customer in here, and basically this is the information on how to get to customer. Now this name right here, application, comes from here. So make sure that you always name your applications. So here, if you change this to foo, in here, this will be foo in uppercase. Now, obviously, if you have more than one instance connected to this server, i.e. 2 customer instances, you should see that we'll have 2 instances of customer. So if I go back to IntelliJ, and in here, let me just open up the configuration, edit configuration. And what I want to do is the following. So I'm going to basically duplicate this. So duplicate custom application. And in here, just say 2. And what I want to do is add some environments, or more correctly, a program argument. So I'm going to say -- and then server dot and then port equals to, and then I'm going to say, let's say 8085. So I know nothing is using 8085. So if I apply and OK, and now I'm going to run customer application 2. So this is a second instance of customer. So run this. So you can see that we have one instance here and another one here. And this right here already connected to the server. But if I go back, now if I reload, have a look. So availability zones, we have 2. So we have 2 instances of the customer application. So this is kind of cool. And you can see that it's actually maintaining the address for all the microservices. So the first instance is available on 8080. The second instance is available on 8085. Now, I said that the whole purpose of service discovery is to eliminate the use of the port and information where the server is running. And I'm going to show you this in a second, how you're going to have microservices talking to each other through service discovery. But for now, I just wanted to show you that if you have a second instance, you'll have basically this number going up in here. So obviously we don't need this second instance. So let me just stop. So I'm going to stop customer 2. And also let me just delete this configuration in here, just like that. Apply and then OK. Now let's do the same for fraud. So I'm just going to take this configuration, open up fraud, and open up SRC, or in fact, let's just have the client. So instead of the server, we want the client, just like that. Reload in here, and then open up the main for fraud application. And in here, this should be @ enable, and then Eureka client. and open up resources, application.yaml, and let's have the exact same information in here, just like that. And also, if you want, you can say fetch. So in here, you can say fetch registry equals to true, and the default is true actually. And then here, register with Eureka, and then true. So if I show you in here, so you can see the default is true for fetch registry, and register with Eureka as well true, but let's just keep these so you know exactly what's happening. So in here, if I open up customer and then paste those in, there we go. And for fraud, let's also make sure that we can run fraud. So open up the fraud application and then right click, run. There we go. And in here, we should see that now we should only have one customer available, and we also should have fraud in here. So if I reload, there we go. You can see that we have one customer application or server up and running, and also we have one fraud, which is running on port 8081. If you have questions getting this far, please do let me know. Otherwise, next, let me show you how we're going to have customer talking to fraud using service discovery. So if you remember correctly, if I open the customer and then service in here, so before, remember that customer makes, so in here, makes a network call right here to fraud by saying localhost 8081. Now I said that the main reason why we use service discovery is to remove this information in here. So localhost and then basically 8081, right? So we let the Eureka server handle this information, and all we need to care about is the name of the service that we want to connect to. So in this case is fraud. So just like this. So you can see that we just changed this to fraud and job done. It's literally, it's as easy as this. So this right here is, so in this page right here is the application name. So fraud in uppercase, and then this will resolve to this IP address as well as this port. Now let's go back to IntelliJ. And what I want to do is open up the application.yaml, and inside of JPA Hibernate DDL auto, let's just say create and then drop. So I'll always want to have a fresh database. So don't do this in production or environments where you want to keep the data, but I just want to have a clean database each time. So here also create and then drop. Now let me restart fraud. There we go. And you can see that we have the database or the create table right here because of create drop. And let's also start customer. So I think customer is already up and running. So let's just restart. There we go, the create table, and we're good to go. Now let's open up Postman, and you've seen this request time and time again. So this request will land in customer, and then customer will talk to fraud. If I send this request, we have an internal 500 internal server error. Let's have a look why. So in here, so unknown host exception. Now what is happening is, let me actually see if I can demonstrate this to you. So remember I said to you that if I basically click on edit configurations and then fraud, I'm going to duplicate fraud, and this will be fraud and then 2, and inside of program arguments say dash dash and then server dot and then port equals to 8085. So this there's nothing running on this port. So if I say apply, okay, and then run, there we go. So now in here, if I reload this page, we have 2 instances of fraud. Now, when we make the HTTP request, currently REST template is confused. So it doesn't know how to handle this request that goes to fraud, right? So it goes to which of these instances. So it has no clue about it. So this is what's happening. So we're making a HTTP request, and from customer, there are 2 fraud instances. How does REST template knows to send either to this instance or this other instance? Well, to fix this, we need to add an annotation to our REST template to be able to load balance the requests. So if I open up IntelliJ, and in here, let's open up customer config, and inside you see that we didn't configure REST template right here, but this bean, we have to also tell it to be at, and then load balanced. So there we go, load balanced, which means that the request can either go to this instance or this other instance. If I open up, so fraud, so where is it? Fraud controller, have a look. We have fraud check request for customer and then customer ID. Now here we have 2 instances of fraud. So fraud right here and fraud as well. So let me basically delete all the logs, and I want to show you that. So here, so before this was a 500, and in fact, let's also restart customer because we added that annotation. So let's reload. There we go. And now if I go back, let's try and send this request and see if it works. So if I send the request, there we go. You can see that this time it works. It's a 200. But what I want to show you is, so if I open this fraud application, so let's see whether we have some logs. Yes, have a look. Fraud request or fraud check request for customer 1. And let's have a look at the fraud application 2. Nothing inside. Now, if I send the request again, so send again, and let's check the logs. Check this out. So this time it landed on the fraud application 2. So this is quite cool, right? Have a look. So basically it's using round robin to distribute the requests. So first it landed on this fraud application running on port 8081, and then this other one running on port 8085. If you have any questions on what happened here, please do let me know. Otherwise, let's move on. So before we move on, what I want to address is this issue where if I open up the customer service class in here, have a look, we have this fraud response class, which lives inside of the customer microservice, but also in here. So it also lives inside of the fraud microservice. So even though they are the exact same thing, right? And the reason is because the controller, so fraud controller, uses it in here, and then it returns the response, and then the customer service basically uses REST template get for object, and then it casts the result to the fraud check response. Now, also in here, we are using REST template in here. Now, you can imagine where we kind of want to reuse this code throughout, thousands and thousands of microservices. Now, this wouldn't be scalable because we kind of have to copy this class around. We also need to know the URL, so on and so forth. So instead, what we're going to do is to refactor things a little bit and use OpenFA. Now, this project provides OpenFA right here. And if you want to learn more about OpenFA, I've got a course that basically teaches OpenFA. But basically in here, FA is a Java HTTP client binder inspired by retrofit, JAX-RS, and WebSocket. So it aims to reduce complexity when using REST clients. So have a look. We have a bunch of these clients, and Faye makes it super easy to provide you all the clients, all the contracts, all the encoders, decoders, metrics, so on and so forth. So in here, let's go ahead and basically change our backend to use OpenFae. And also you can always, so in this Spring Cloud OpenFae, if you click on Learn, you can click on Reference Docs, and you have some examples on how to use it, so on and so forth. But don't worry, I'm going to teach you how this works. Next, let's go ahead and refactor our code a little bit and introduce OpenFae, which will be a much better implementation. Okie dokie. So within IntelliJ, let's refactor things a little bit. So what I want to do is to create a new module in here. And this module, I'm going to name it as clients. So this module will be responsible for having all the clients that we're going to have for our microservices. Also, you can have external clients, meaning that, for example, if you are connecting to Facebook's API or Google's API, then you can put your code in here as well. So I'm going to say finish, and also in here, so leave things as default, finish. Now within this pom.xml, I'm not going to add anything, so we don't need anything just yet. And what we're going to do is let's open up src main, and then within Java, new, and then package com.amigos code dot, and then clients. And then within clients, let's create a new package, and this will be fraud. So this is where we're going to have the classes related to the fraud client, right? So how we're going to connect to the fraud API. So here we have one package, fraud, but then you'll have another one for notification, so on and so forth. Now in here, let's create a new class and just call it as fraud, and then client, and make sure that this is an interface. Now within this interface, let's annotate this with add, and then Faye, and then client. Now this is not working, and that's because we need to add the dependency. Now what I would like to do is for every single other project to be able to use the Faye artifact. So let's open up the main POM in here, and within dependencies, not inside of dependency management, but within dependencies, let's have a new dependency, and this will be Spring Cloud dash starter dash, and then open, and then Faye, just like that, and then reload. So let me just put this full screen so you see everything. There we go. So we are good to go. Now if I go back to the fraud client, in here we can import the class just like that. Now inside of this class we have to pass a few things. So one is, so if I press Command P in here, so I just want to show you that. Have a look. We have value, we have URL, fallback, path, so on and so forth. So when we move to Kubernetes, you'll see that this will change a little bit, and because we are using Eureka Service Discovery, so let me just go to the docs, and in here, so they have, so have a look, the load balancer client will discover the physical address for store. So this is the example for this client in here. If your application is Eureka client, then it will resolve the service with the Eureka service registry. So this is exactly what we have. So let's go back to IntelliJ, and in here I could just say fraud, and because I want to define the path, I need to say value equals to fraud, and comma, and then path, and then the path is API /v1 / and then fraud. So this path in here is, so this one. So if I open up fraud, and then fraud controller is this one right here. So API Oh, actually, it's fraud check. So fraud and then check. So you could leave things like this, or you could just take this. So take the path and remove everything basically. So I'm just showing you a different way of doing things, just like that. And then inside, we need to basically have the API that represents fraud. So if you have a look at the fraud controller, we have this guy right here. So let's just take this get mapping and go back to fraud client, paste that in. And at this point, we just have to do this. So here, just remove all of that, remove the body as well. And because this is an interface, so you'll see how this is going to turn out to be. So here, we don't need this as well. And we need to end this with semicolon. And then for the path, so in here, so because we didn't include the path in here, we have to say API v1 / fraud check / and then customer ID. Now we also need to have the fraud check response. So in here, let's just take the fraud check response, Command C, and then paste it in and have a look. Now the error went away. Now at this point, so if this is a little bit confusing to you, but basically what is happening is, so this is our fraud client in here, and this right here is an interface which will target fraud controller. So this controller, so it's the exact same thing, but without the method body. So this is OpenFA in action. Now, at this point, you can see that we can then start removing a couple of things, including this class in here. But this is the client that we have now, that any microservice that wants to talk to fraud, all they need to do is just use this interface and then job done. Next, let's change customer to use this client. So to have customer to use this client, we have to do the following. So inside of the customer, so customer microservice in here, open up the pom.xml, and we need to include the dependency. So this will be a dependency, and the artifact will be clients, and this is from com.amigos code, and then snapshot, and also let's define the scope, and this will be compile. Now this right here is the version that you see in here. So this version right here. So obviously there are better ways of doing this, but for now, this is the simplest way for you to get this up and running. So now inside of customer, so customer, open up Java, and inside of the main class, so customer application, we have to do a few things. So one, we have to say that we want to enable, so at enable, and then FA, and then clients. And remember, we added the FA artifact to all microservices. So here inside, we also have to specify the base and then package. So this is because the client lives in a different package. And this is from com.amigoscode. And then client. And IntelliJ doesn't seem to resolve this package. So let me just reload in here. And still doesn't, and that's because, so src main Java, so this is clients in here, so it should be clients and not client. So you see that now it works. So now let's open up the customer service in here, and what we can do is, so within this class, we can basically say private final, and then fraud client, so we can inject it. And now, instead of doing all of this, we can just say, so in here, if I put this full screen, just like that, so I can say fraud client dot, and then is fraudster right here. And then all I need is to pass the customer dot get ID. There we go. And this will give me the fraud response in here. So fraud response. So I'm just going to leave things the same. And now I'm going to basically delete all of this. And there we go. So if I put this on a new line, just like that, and this is giving me an error, and that's because we no longer need this class. So let's just delete this class called fraud check response within the customer microservice. So let's just delete anyways. And here I can import the one from our client's module. There we go. And you can see that this now works. So this is beautiful stuff. So if I open up fraud in here, so fraud Java, and then in here we can also get rid of this class right here because we don't want to have duplicates. So let's just get rid of that. And then within fraud controller,